So, welcome everybody. I hope you had a good night, either at the party or in your bed or whatever you did do. As I've been asked to give this talk in English. I hope if you don't speak German, that my English is well enough that you can easily understand me. If you do speak German, I hope that as well. And I'm going to talk a little bit about JavaScript. And as you've been told, my first initial reaction was, okay, but I don't have anything to do with Oracle. And maybe your first reaction was, okay, but I don't have to do anything with JavaScript. So the first thing I would like to ask you is, who of you knows that a thing named JavaScript does actually exist? Okay. Who of you uses JavaScript regularly? That's less, as expected. Of those who use it, who of you likes to use it? Less, as expected. Of those who use it and who like to use it, who of you thinks that JavaScript is the best language ever invented? Okay, I'm out of scope here. Okay, to be honest, I don't think that JavaScript is the best thing ever invented either. And if you are new to JavaScript, or even if you do JavaScript for 20 years now, but it never felt right for you. To many people, JavaScript somehow doesn't feel right. And this is the first thing I want to clarify where this comes from, because there is a reason for that, why JavaScript is often seen as a strange language, and it behaves in a strange way, and it is somewhat quirky. And, well, the problem is, if we imagine that you are flying in an aeroplane and somewhere at the surface of the Earth there's some code being written and you can't figure out all those details from 10,000 feet above, but what you can realize is that the code somehow contains those characters, curly braces and a semicolon. And since you are 10,000 feet away, of course you can't figure out which language this is exactly, but you can guess something. And maybe it is C, maybe it's C++. By the way, this is where the term legacy code and legacy C++ code comes from. Okay, so maybe it's Java, maybe it's C#, but no matter which language it is, it will be a language of the C family, most probably. And then comes the day when you, for the first time in your life, meet JavaScript, and you don't know anything about this language. And what you see by looking at other people's source code is, oh, curly braces, a semicolon. So this must be a language that originates in the C language family. This is pretty obvious, and this is damn wrong. And this is the biggest mistake you can do when you do JavaScript development. Seeing something that looks familiar and then thinking that hence it should be familiar. Unfortunately, JavaScript has nothing to do with C. The only thing they share is the syntax. So if you only remember one single sentence of this entire presentation, then it should be JavaScript is not C. And don't treat it as if it was C. The big question is, if it is not a C-based language, then what is it? And there's another language that you can easily distinguish from each other language by looking at some syntax elements. And this other language looks somewhat like this. And I've already heard it. It's Lisp. Who of you has done Lisp? Oh, well, around 10 to 15 people. Okay. And you can easily imagine what the most common error for newbies is. Figure out which one is missing. Have a lot of fun. Lisp is actually the second oldest programming language. It's from 1958. The only one that is older is Fortran. At least if we take the term programming language in today's meaning. We don't mean punch cards or something like that. And Lisp is a very, very interesting language, a part of all those parentheses. If you have done Lisp for 3 days, you don't see them anymore at all. They become invisible. And Lisp is a very interesting language. And if you now wonder why does he tell a little bit about Lisp, you will see in 2 minutes. The general idea of Lisp is you have things such as numbers, you have strings, and example given the number 23. And a single number or a single string or a single character in Lisp is called an atom. And yeah, what can you do with a single atom? Obviously not too much. But what you can do with Lisp, Lisp itself is an acronym. It stands for list processing. So it is a language that cares about lists. And a list in Lisp is pretty simple. It's just a pair of parentheses. So this is the empty list. And what we can do now is we can put atoms into lists. So we can create the list that contains the atom 23. If you would like to put more things into a list, you can separate them by space. And yeah, now we have a list of 3 items or 3 atoms. And that's it. Now you know about 98% of the syntax of Lisp. Actually, there isn't more to it. Okay, there is, but that's 98%. Now, the general idea in Lisp is we can process lists, and the big question is, to process something, we need some code to be run. So this is obviously data. How do you run code? And running code, yeah, often means calling functions. So how do you call a function in Lisp, example given? Well, a function call is basically nothing but a list, because you have the name of a function, and you have 0 or more parameters that you would like to hand over to that function. So in Lisp, example given, there is a plus function, and this is actually a function, it's not an operator. So to add 2 numbers, you say, I would like to call the function plus and hand over 2 numbers, and this gets evaluated to 65. So there's a general, very easy pattern in Lisp. The first thing in a list is the name of the function you would like to call, and anything else is the parameters. So if we would now, the result of course is 65, if we would now like to divide that result by 2, example given, you can, or you have to wrap this in another pair of parentheses. Yeah, now we see to start a pattern. You divide this by 2. This is how Lisp works. Now, it's obvious that this will go wrong, because this means call the function named 23 and hand over 42 and 17. And this is not exactly what we wanted to have. We wanted to have a pure data list. So we can quote this list, and now it means don't try to run this as code. And so what we can now see is that in Lisp we can easily use the same syntax and the same language elements, that is atoms and lists, to represent data and to represent code. If Lisp is an acronym for list processing, well, what do we expect? Well, this language will probably have functions such as concatenate 2 lists into 1, or reverse a list, or take an atom and a list and put that atom into the list, or give me the 5th element from a list, and so on. And this is what you can do with Lisp very easily. And now, so far, this is a strange syntax, and yeah, it's a very simple syntax. And now the point comes where you see why Lisp is the most awesome language ever invented. And I mean that absolutely serious. The point is that you can have functions to get the first element of this list. Example given, to get the first element of a list, you have to call another function, and this function is char. If you wanted to get the rest of the list, it would be cdr. If you wanted to get the second element, it would be take the rest of the list and then the first element. So you would call char of cdr of the list, or cater. And this is how Lisp works when you try to access lists. And now, the interesting thing is you get back a 23. So this results in a 23. If we do the very same thing on code, we get back the divide function. So you can use the language to manipulate data, and you can use the very same language and all the same patterns to manipulate code. And of course, you can not only read items from a list, you can also write them into a list. So you can write code that writes code. Or you can write code that manipulates code at runtime without any hassle. And yes, you can do that with Java as well, or you can do that with C# as well. If any one of you has ever tried to figure out how this works, after 4 weeks of reading the documentation, maybe it was not that much of fun. And in Lisp, this is really, really, really easy. And the question is, who needs self-manipulating, self-adjusting programs? I always made the joke, well, Lisp must be a great language to write viruses. Okay, maybe not the best use case. Where this really gets interesting, if you try to write programs that learn and that adjust their behavior to other circumstances and who adjust themselves to a new environment. So this is pretty interesting for machine learning, for artificial intelligence, and this is where Lisp is strong for 60 years now. Unfortunately, this is the only place where Lisp is strong, because in every other area, nobody wants to deal with this here. So this is a short history of Lisp. Now, what's really amazing about Lisp is that its syntax is so simple. I can teach it to you in 5 minutes. But on the other hand, it's so powerful that you can do meta-programming in it. And this is the absolute contrast to this is Visual Basic. You have 700 keywords, and every 5 minutes you hit a wall where you are being told, oh, you can't do this, you can't do that, this doesn't work, because there's no keyword for that. Lisp is way more flexible. Okay, so this was in the, mind you, 1958. So this is a pretty long time. Okay, now let's fast forward to 1995. In 1995, Google was not founded yet and not even invented. Amazon was pretty new, eBay was pretty new. If you wanted to go to the web, you had to pay lots of money, and it was really, really, really slow. And if you wanted to place an order at Amazon and you mistyped your zip code, because when you hit enter, you also hit the hash sign, then it took 2 minutes for the Amazon server to send the answer back to you that, oh, sorry, you mistyped your zip code. So a nice little company called Netscape had the idea. They made a browser, by the way, for the younger people. Last year, I've given a lecture on JavaScript at a university, and I talked about Netscape, and then after a few minutes, one of the students put his arm up and asked, "What is Netscape?" And this shows you, okay, you're not the youngest person anymore. So Netscape made a very famous browser back then, and they had the idea, what if we introduced a client-side programming language so that people could validate forms before submitting them? And they thought that this would be a good idea, and so they decided, okay, let's put the client-side programming language into the browser. Unfortunately, 1995, unfortunately from the point of view of Netscape, Microsoft released Windows 95 with Internet Explorer 4, and Internet Explorer 4 was the big competitor to Netscape. So it was obvious that Netscape couldn't take the time for 3 years and design a language and make it up and make it perfect and so on. They needed to be fast, because Netscape earned money with their browser by selling a browser. You have to think about paying money for a browser. That was true back then. And Microsoft gave away Internet Explorer for free as part of Windows. So, yeah, pretty bad situation if you're Netscape. So they needed to be fast. And if you need to be fast, and you need to build a programming language runtime environment, well, you need some time. There are a few people in the world I think, that are able to come up with a programming language runtime environment over a weekend. I once had a colleague. He was one of those persons. And it could happen it actually happened on a Monday morning that we met, and he asked how my weekend was, and I told him, yeah, we had barbecue. And then I asked how his weekend was, and he told me, yeah, I've learned Fortran. And I said, whoa, okay, why? Oh, just out of curiosity, okay. And how did you learn Fortran? Oh, I wrote a compiler for it in COBOL. And my reaction was, wow, you know COBOL? No, I learned that as well. And so he, at a later point in time, went to Google, and yeah, there are people who can do that, but I personally can't do that, and I don't want to blame any one of you, but I think most of us won't be able to do that in a weekend as well. So anyway, Netscape said, okay, we need to put a language in our browser, and we need that fast. So they thought about embedding C in the browser, but no, bad idea. C is way too complicated. We need something simple, really, really, really simple, but which offers huge opportunities to developers. So they went back in time 40 years and figured out there is a language with minimalistic syntax and impressive opportunities, and this language is called Lisp. So let's embed Lisp in the browser. The bad thing is that Lisp hasn't gained traction in the mainstream for 40 years now, so it's not very probable that it will happen in the next 10 years. So maybe we should use Lisp, but make it look a little bit less like Lisp. And since everyone knows C languages, let's just replace those parentheses by curly braces, and then it looks familiar, and add semicolons. And then we have a new language which is impressive and powerful, but simple and minimalistic, and everybody should be able to work with it. What could possibly go wrong? Yeah, okay. Unfortunately, C and Lisp is like two completely different things, and of course this didn't work out. The funny thing is that if you know Lisp, this is my summertime activity each year, taking a Lisp book and reading it, and I haven't worked with Lisp in production, never, but I find it very interesting because you can learn a lot of this language. And so, yeah, they did that. And then they needed a name. And if you think back how it was in 1995, what was hip in 1995? Oh, Java was new. So let's do something with Java. I mean, it has nothing to do with Java, but let's jump on the train, and maybe we can take a part of its glory. And in 1995, everybody believed that using Java in the internet would be a great idea. Java applets, anyone? And it didn't work out, at least not in the front end. In the back end, it's a different story. But this is how they came up with the name JavaScript. So now we have a language that looks like C, that is named after a C language family member, and that does work in a way that is completely different from how C works. And this is, if you don't know that, why people have problems and are struggling with JavaScript. So the single advice that I would like to give you if you try to deal with JavaScript is, first, forget everything that you have ever learned about C. Don't fall into the trap of thinking, oh, curly braces and the semicolon, it has to work the way I expect it to be, because it won't. And lots of people don't know that, and it doesn't work as expected. So what's happening? Strange things are happening. And then, of course, nobody says, oh, it may be my fault because maybe I interpreted those curly braces in a wrong way because, hey, I'm doing programming for 20 years now. I know how curly braces work, don't I? Everyone blames, of course, the language for being crappy, and this is where the bad flavor of JavaScript comes from. By the way, when Netscape looked for someone to implement this, they found one. His name is Brendan Eich. And Brendan Eich is, let's call him the mastermind behind JavaScript, and he has written a blog post once. And he wrote that he had 10 days to implement JavaScript. And the problem is that if you have 10 days and you build a programming language, nobody cares. But if you have 10 days and you build a programming language and suddenly 1 billion websites use it, you have a big problem. Because not everything may be designed that well. And there are a few things I would like to show you where you have to watch out for, that you have to watch out for in JavaScript. And the first thing is pretty simple. We have variables, and we have, of course, constants as well. So you can do something like const a is equal to 23, const b is equal to 0, and now we say, well, the result is equal to a divided by b. If we save that, let's store that in, yes. Okay, let's cut that, close that file, create a file. That's way easier. So let's put this here. Now we get syntax highlighting and so on. And if we now try to run this, the big question is we are dividing by 0, so what do you expect to happen? Of course, you hope for an error. Of course, this is JavaScript. This is not what is going to happen. If you divide by 0, you won't get not a number, and you won't get a division by 0 exception. You will get nothing, because I should print it, actually. So let's add a console.log. If we now run this, you get infinity. And if you think about math in school and calculating limits, and if you think about the 1 divided by x function, it looked something like this. And the further you went to the right, the closer it got to the x-axis, and the closer you got to 0, the closer it got to the y-axis. So if we are calculating 1 divided by 0 for very small x, it becomes a very, very, very large value. So the reasoning is JavaScript is great if we would like to do calculations like calculating limits. Maybe not. Okay, the reason for this is it's not as strange as it seems, because if we do the very same thing in C#. Suppose we have something like this. A is 23, B is 0. The result is A divided by B, and then we have a console.writeLine of result. You expect at least C# to do the right thing and to throw an exception, but you won't get one. You will get infinity. Why is that? Because this is not integer arithmetics. This is arithmetics for double precision floating point numbers. And they follow the IEEE 954 standard. And the IEEE 954 standard says if you have 2 floating point numbers in double precision and you divide by 0, the result should be infinity. So this is why this code in C#, and by the way, Java behaves in exactly the same way, doesn't throw an exception. It only throws an exception if you replace double by int, because for integer arithmetic, division by 0 is not defined. But here you will get infinity. And what you need to know about JavaScript example given is that everything that looks like a number, there's only one data type for numbers in JavaScript, it's called number, and everything that looks like a number is of type number. And number internally is always double precision floating point. And this is, although this looks like integer arithmetic, it isn't. This is one trap you can easily fall into if you do JavaScript. While we are talking about C# and Java, there are a few other things that you might experience that come a little bit as a surprise. What's the biggest difference between Java and C#? Well, pretty simple. Suppose you define a method, public static void main. This is neither Java nor C#. This is what it would look like in C#. And this is what it would look like in Java. Now, despite the casing of the function name, the one big difference is where to put the opening curly brace. When I was a student, we had, besides the lectures, we had for 6 months, we had an exercise where we, in pair programming with another student, where we developed a clone of eBay to learn about how Java EE works. And I had a C# background, and my companion had a Java background. And it was also the first time ever that both of us worked with the versioning control system. And we couldn't agree on where to put those opening curly parentheses. So the result was that for literally 6 months, every time one of us opened a file, we reformatted the code. And you can imagine what our commits looked like. So with every commit, you have 9,000 changes. 8,937 of them are curly brace to the next line, curly brace to the previous line. And that we did that for 6 months tells more about us than about the languages that we used. But anyway, and in the end, it doesn't matter. You can put those opening curly braces wherever you want, because it doesn't make a difference. At least if you are in Java or in C#. In JavaScript, you are always being told, always put those curly braces to the end of the line. It's a mistake to put it here. And every normal person thinks, why? So the reasoning for this is pretty simple. Suppose, as you have seen, there's the console.log command, which we can use to say hello world example given. And if you have those 2 lines, then you expect this to be a syntax error in the second line, but actually it isn't, because semicolons are optional in JavaScript, which is one of the worst ideas in JavaScript ever. So what happens is that JavaScript, it runs line 3, and when it comes to line 4, it says, oh, there's a line without a trailing semicolon. Let's insert one, because they are optional, and it still looks like valid code, so I'm going to run it. Okay. So now suppose you have a function like we would like to add 2 numbers, left, right, and this function returns the sum of those 2 numbers. Then, of course, if we now say add 23 and 42, and we console.log the result, and if we run this, of course, we get 65. Now suppose this calculation is a little bit more difficult, and maybe the variable names are a little bit longer, so you would like to split this line into multiple lines, and you think that it's a good idea to introduce a line break here. Makes the code more readable. Now, what happens is JavaScript runs this code and says, oh, well, a line without a trailing semicolon. Let's insert one. Of course, the return statement without a return value is perfectly valid code. In JavaScript, this returns implicitly the value undefined. And this line of code, well, it's an expression. As an expression, it's valid. It looks right. Nobody cares about it. And anyway, it's unreachable code. So if we now run this, oops, we have undefined. So you've broken your code by introducing a line break, because even, okay, I had the semicolon in there, even if we remove the semicolon and run it, you get undefined. So the rule is pretty simple. Always end lines in a way that it doesn't make sense to add a semicolon to it. Like, let's put the result in parentheses. They are not needed by the return statement. They don't have any sense. The only reasoning for them is, if you add a semicolon here, it looks like a smiley, but it's not valid code anymore. So JavaScript won't introduce a semicolon here for you. So yeah, do that. And if we now run it, you see we get 65 again. Unfortunately, this only works if you put this parenthesis at the end of the previous line. If you move it, of course, to the new line, you have the same problem as before, so you get undefined. So this is the reason why opening curly braces and opening braces in general in JavaScript should always be put to the end of the line, so that you don't have to think about these things. Another interesting thing in JavaScript, which regularly breaks your neck, is there's a keyword, that also looks very familiar, and this is the this keyword. Everybody knows the this keyword from Java and from C#. So suppose you have a class, let's say you have a class dog, and this class has a constructor, by the way. Yes, this is actually valid JavaScript code. God bless you. JavaScript has a class keyword. It even has an extends keyword. We still don't have classes in JavaScript, by the way. It's object-oriented, but it doesn't have classes, although there's a class keyword, but this is a different topic. Okay, so we have a constructor. It can have a name, and of course we can assign the name to the dog, and then each dog can bark, and maybe the dog says woof woof. And since it's a very intelligent dog, the dog can bark its name. So we are embedding here this name. And yeah, finally we say, well, we now have a concrete, a specific dog. I'm going to call this dog Alice. We have a dog whose name is Alice. So we can here say Alice. It's a new dog. And then we can say alice.bark. And of course, you now expect that it should give you this. And of course, it will work. We get woof woof Alice. So everything fine here. It works as expected. Now you say, well, okay, Alice is actually a very intelligent dog, but she's not as intelligent to bark her name. At least maybe she needs to think about it for a while. So let's delay this for a second. And you say, well, I'm going to add a set timeout call here. Set timeout delays something for a number of milliseconds. Let's say she needs to think about this for 500 milliseconds. And after 500 milliseconds, we would like to run a function. So you say, we've got a function here. This is basically a callback function. And after 500 milliseconds, we would like her to say woof woof and Alice. So what could possibly go wrong? When we run this, of course, we get woof woof undefined. And things get worse. Has any one of you ever programmed in Visual Basic? It's okay. Me too, by the way. And Visual Basic is a very interesting language in that it is very beginner-friendly. And Visual Basic, or Basic in general, is very beginner-friendly. And Visual Basic, if you don't do things in exactly the right way, Visual Basic doesn't give you an error. It says, okay, this is not perfectly valid syntax, but I'm trying to figure out what you meant. So sometimes it will work anyway. And of course, this is nice for beginners, but a bad idea if you are more advanced. So yeah, same problem. We cannot change basic because too many people rely on it. So they introduced a compiler flag. And this compiler flag, you needed to opt in for a more strict mode of Visual Basic. And this was called option explicit on. And in JavaScript, the same idea revived. So we have a strict mode in JavaScript, and we enable it by simply adding the string use strict at the top of a file. And in general, it's a very good idea to have that at the top of each of your files. And if you switch on strict mode, example given, you cannot use global variables anymore. That global variables are a bad idea. I don't think that I need to talk about this. That should be pretty obvious. Now, you remember that we got woof woof undefined. If we now simply add use strict, we get still woof woof undefined. Okay, yeah, this is, yeah. You see that even if you do JavaScript for a long time, sometimes things don't work the way as you'd expect them to. Okay, anyway, why is this undefined? The point here is, from C# and from Java, you are used to that this always refers to the instance I'm currently in, and since the bark method, or the bark function, is defined in the dog class, you would expect that this always points to the current dog. And this is how Java and C# work. In JavaScript, it's different. In JavaScript, it depends on how a function is called. It worked in the beginning because we say alice.bark. So since we call the bark function on the Alice object, this points to Alice. If we use the set timeout call here, now something different happens, because when we get here, then this, of course, is equal to the Alice object. And the set timeout call, there's one thing that you need to know about that is it doesn't block your thread. It's not like a thread sleep. And it doesn't block your process. It's more like setting up an alarm clock. So this call to set timeout immediately returns. So example given, if we put a console.log here, something like finished, just to show that, finished will happen immediately, and then after a short amount of time, the callback is run. So this is an asynchronous call. And so this means that here, this is also equal to Alice. And we set up the alarm clock and say, once the alarm clock rings, run this function. Of course, this function, we don't call that function. This is called internally by JavaScript, by the runtime. And the problem is that JavaScript doesn't have the slightest idea that it should call this function on the Alice object. So there's no relation between this function and the Alice object. So this points somewhere. And somewhere we don't have a name property. And if you try to access a property of an object that doesn't exist, you don't get an error, as you'd expect, but you get undefined. And this is why we get woof woof undefined. So the this keyword can be more of a problem. And then people tell you, well, it's nice in JavaScript that you can hand over functions to functions and that you can return functions from functions, and it's a very function-driven language. And there's a short new great syntax for functions so that you don't have to type function, 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 function all the time. And this short syntax is, it looks like this. You may know it from C# or from Java. It's a so-called lambda expression. And people always tell you, well, that's a short syntax form for a function. This is only half the truth, because the entire truth is that this arrow here also binds the outer this to the inner this. So this magically changed our inner this. So in here, we now, this here is still the Alice object, because this fat arrow gets this outer this into here. So if we now run this, you'll see that things work. Okay, so, and we could go on like this for days. And there are little small traps. I just wanted to show some of the things that don't work as you may expect them to. Interesting things can happen if you try to do comparisons. Example given, if 0 equal to 0, then console.log yay. So if we run this, of course, the string 0 should be equal to the string 0. So if we run this, we get yay. So this works, obviously. Now, what happens if we compare the number 0 and the string 0? Of course, they should be different things because they're different types. Of course, they are equal, because JavaScript says, oh, well, a number, and oh, well, a string, maybe it's a good idea to call toString on the number. And yay, we can convert it to a string, and they are equal. So what definitely should be different is the number 0 and the empty string, because toStringing, the number 0 results in the string with a 0 in it, and the string with a 0 should definitely be something else than the empty string. If we run this, of course, they are equal. Because if toString is not fine enough, there's also another method called value of, and the value of the empty string is the number 0. So JavaScript gets very creative in trying to match two things. And one of my current favorite riddles is how do we get JavaScript to evaluate this to true? X should be 1 and X should be 2 at the same time. And of course, we need to introduce X with something. So let's try it like this. And of course, fortunately, it doesn't work, okay. But of course, we can make it work. We simply say, well, X is an object. X has a property. Let's call it, the property's name doesn't matter. Let's call it, we could call it value, but value looks like a property with a special meaning, so let's call it foobar, or Apex Connect, or whatever. And let's give it the value 1. And we are going to override the value of function. And we now say, when you call value of, we return this.apexConnect and increase it by 1. So now, JavaScript, when it comes to this comparison, says, well, object and number is definitely not the same thing. ToString doesn't have the desired result, so I'm trying to call value of x, and well, it returns Apex Connect, so this is 1, and 1 is surely the same thing. And yeah, then it evaluates the second part of this equation, and then meanwhile, the property Apex Connect has been increased by 1, so now it returns 2, and 2 and 2 are obviously the same thing. So now you get yay. And by the way, of course, you can make a lot of fun about JavaScript, but the same thing works in every other language as well. Maybe not with value of, but I have been doing very much C# before I switched to JavaScript, and it's perfectly possible in C# to get this code running, console write line A. A is bool, and bool A, get value for A. And then we have another bool B, get value for B. And when you then say console write line A, it returns true. And you say console write line B, B, and it's true. And then you say, well, console write line A equal to B. Of course, if A is true and B is true, the result should be true. And you can get C# to actually print out false. So it's possible in every language to fuck up. The question is just how. If anyone is interested in how this works, you may ask me after the talk. So there are ways to use a language in a way it was not designed for. And we can go on for a very long time like this. But there are things that you can do with JavaScript very easily, where you can get very creative on your own. And I would like to show that to you. As you may have noticed, I have not yet opened a browser. So I always ran Node app.js. So the question is, what is Node? Node is a runtime environment for JavaScript, which has been designed for the server. So JavaScript is not necessarily tied to the browser. So we can, here is nodejs.org. You can see that there are two versions, version 8 and version 10. I'm using version 8 right now, I think. I'm not pretty sure. Let's just have a look. Yeah, it's version 8. And what you can do with Node, you can run JavaScript files as we've seen, or you can start it without a file name, and then you can evaluate JavaScript interactively. So, and now what I'm going to do, I'm going to write a little web server with some REST API, and well, we've got around 10 minutes left. This should be difficult if I had tried to do this with Java or C#, because then those 10 minutes would be taken for opening Visual Studio or Eclipse. In JavaScript, fortunately, things are way easier. And by the way, if you don't believe that JavaScript is actually easier, I have a daughter. She's 9 years old, and she's interested in computers a lot. And at the weekend, when we have time, I'm teaching her a little bit how to program, and I can perfectly explain to her what console.log hello world does. I have a hard time explaining what public class program, public static void main, and so on means. So this definitely is easier. And it does not only stay easier for hello world programs, it also is easier if you do more complex things. I'm in the fortunate situation that I have 10 years of experience with C#, and so I can compare those two languages pretty well, and you definitely write way less code in JavaScript. Writing way less code means less chances for errors, less code to read if you want to maintain it, if you want to extend it, whatever, but you have to have a good discipline. So JavaScript lets you do lots of things, but you have to deal with some things. So that it's called JavaScript is not only bad because it puts this language close to Java where it shouldn't be, because it isn't related to Java in any way. It also implies that it is a script language. Yes, it is a script language, but script languages always have those oh, it's just a script language. You don't have to take that for serious. And this is another very common mistake, that you think, oh, it's a simple language and you can't do anything reasonable and serious with it. So why bother? And yeah, with great power comes great responsibility, Spider-Man principle. And JavaScript gives you a lot of options because it's Lisp at its heart. This is why this is really important to remember. Okay, so now I wanted to set up a web server. Yeah, building a web server. Okay, what do we need? We need a socket, and we need some way to parse TCP streams, and whoa, this sounds difficult, unless you use Node.js. Node.js has a number of modules included already out of the box. Think of it like the .NET base class library, the CLR, the BCL, or the Java class library with 100,000 or millions of classes. Node is not that big. It just has modules from A like assertion testing to Z like zlib. So this is the entire documentation. If you have a free Friday afternoon and would like to read the entire Node documentation, that's perfectly possible. And there are only a very small number of things included in Node, which does not mean that you can't do much with Node. And you can see that here we have an HTTP module, and now I'm going to import this HTTP module into my code base. So what this gives me, it has a create server function, and this function creates a web server. And of course, so to run this web server, we need to bind it to a port. For historical reasons, we always use port 3000 in Node, but it doesn't matter. And now we have a web server. It does not yet do anything. We have a callback for this. So we get in a request and we send out a response. And the simple thing that we can do is say we write hello Apex and then close the connection. And now if we run this, you see that your program doesn't end anymore. Maybe it's hung, we don't know. But if we now try to access localhost 3000, you can see that we get hello Apex back in the browser. So we've got a running web server. Okay, this was easy. Now, maybe we would like to define some routes, and if you get something or if you post something, unfortunately the HTTP module can't do that. It's a very low-level HTTP library, and routing, yeah, is not there. Fortunately, there's an ecosystem of open source modules around JavaScript, and there's a package manager for dealing with this ecosystem, and it's called NPM. NPM is the Node package manager. It's similar to Maven in Java or to NuGet in C#, and it's the largest open source repository in the world, although it is only a few years old, and it's the fastest growing open source repository in the world. And NPM published a number of statistics this week, and in 7 days they had 5 billion downloads. So this is pretty much. And yeah, so if you would like to use a module from NPM, we have to add, oops, not a folder, we have to add a metadata file which describes our application. It's called package.json. We have a name, and the name could be Apex demo, and the version could be 000. And now we say we would like to install the Express module. So we say npm install Express, and if the wireless network likes me, this is pretty fast, it is. So now it was installed, and as you can see in the package.json we have an entry, so we make this dependency explicit. We depend on Express in version 4.16.3. And now we can say we would like to load Express. So let's require this. And then we can say, well, I would like to create an Express app, and this Express app should react if someone tries to get the root path, and if we do so, we send back some text like hello Apex. So like this. And now, instead of handing over a function to create server, we're handing over the Express app. And maybe some logging would be nice so that we can see that the server has actually been started. So we install another NPM module for this. It's always the same in the JavaScript world. You want to do something, and you ask, how can this be done? And the answer is always, there's an NPM module for this. A few years ago, my mother's notebook went bonkers, and she needed a new one. And I told her, maybe it would be better to use an iPad, because she is the typical consumer. She likes to travel, and she looks where to go and book flights and things like that, write emails. And I never, when she had a notebook, I never had the moment where she called me and said, hey, I figured out how this can be done. I only got those calls, something doesn't work, like half of my screen is gray. And you try to figure out for 3 hours why half of the screen is gray, because the Windows taskbar has been resized and put to the left, things like that. And since she has an iPad, she was very skeptical in the beginning. And in the beginning, my usual answer to her question, how does X work, was there's an app for that. And now it's vice versa. When I say, oh, maybe I have lost that sheet of paper where I put my notes, my mother says, well, there's an app for that. And yeah, so this is really, really, really great, and I highly appreciate that, and this is fun. And basically with JavaScript it's the same, so whenever you have a great idea of how to get rich and earn money, and so chances are very high that someone else has already created an NPM module for that. And it there is only one global namespace for all NPM modules, so finding good names, it's a little bit like with the domain names and domain grabbing and so on. So we ourselves as a company started to use German names for NPM modules because chances for them were better that they are still free. And we have created a logger called Flaschenpost. It's the German word for message in the bottle. And because like a message in the bottle, you put some sheet of paper in the bottle, throw it into the water, and maybe at some point in time, someone will have a look at it. It's basically the same with log messages. And so we can require Flaschenpost here. And so like this, then we need an actual logger. So let's say flaschenpost.getLogger. And now we can say, once we are listening, we would like to put an info message using our logger, like server start or the server running. And port is 3000. 3000, this is not dry, this is not don't repeat yourself, this is wet, write everything twice. Maybe we should extract this to a variable, maybe we should not only extract this to a variable, but also put it in an environment variable. How do we read environment variables? Of course, there's an NPM module for this. So we install process env, example given, and we now say, well, process env require process env, and we then can say, well, our port is process env port, or if not given, we would like to fall back to 3000, and then we can here say port, and since it's annoying to write port, we can simply get rid of one of those, and it still works. So if we now start the server, like node app.js, you can see that we have the server running. We get a nice human-readable output. If we ran this using a script, or if we redirected output to a file in any way that is not an interactive mode, then we would get JSON objects as output, which is very flexible for logging. So now the server is running. And if we now try to access localhost 3000, we get hello Apex. It's now nicely formatted. It's not plain text anymore, it's HTML. You can see that because it's not Korea anymore, but Times New Roman. Well, yeah, we replaced one ugly font by the other ugly font. But nobody builds websites like this anymore. Of course, you would like to have a REST endpoint which produces JSON. So let's mock a database for now. I know that this is a conference related to Oracle, so please. So I'm sorry that the only thing that I'm not showing is a database. But it's possible, of course, as well. So maybe we have something like a number of articles. It should be an array. Yeah, there's of course an Oracle driver for Node. There's probably not one, but 37. So the first thing would be to figure out which one to use, which one is maintained, which one is error-free, and so on. And to be honest, I don't work with Oracle that much. I'm very sorry for that. And we can now say, well, each article has a name. For example, we sell conference tickets. So we have a conference ticket normal, and it costs, I don't know what your conference tickets cost, let's say 500 euros. And there's an early bird ticket, and this is, of course, cheaper. And then you also have the option to buy a diversity ticket, which helps which is more expensive. And part of this, what you pay more, is used to offer cheaper tickets to people who can't afford the normal ticket. So, yeah, that was a difficult explanation of how diversity tickets work.
We call that next year.
Yeah. And now we would like to send back, of course, the articles array as JSON. The unfortunate thing is that, yeah, with send we get HTML back, but fortunately there's the JSON method, and we can now say, well, we send articles back. So if we restart our server and if we access this, you can see that we get JSON, and it's actually with content type application JSON. Okay, last thing, I would like to address a single article. So with an article ID. So I'm adding a parameter here. And, well, the easiest thing would be to say, well, we just take the index of the array for now. So if I call /0, we should get the diversity ticket. So we need a way to use this value, and we can here say ID is request params ID, and write ID here, and then we should get the first entry of this list. And we should add a 0 here, and as you can see, this works. So now we've created a REST API that supports JSON. Of course, this is only reading. Writing to it is not really, really way more difficult, but time is over, unfortunately. But I think that you have seen that JavaScript is not C. So remember the this keyword, remember some other of those strange behaviors I've shown to you. So the bottom line should be, take JavaScript serious. It's a known language. It has its own concepts. So try to give it a chance and try to take it with an open mind and try to learn it as if it was a new language. It is maybe a new language for you. Learn it from scratch, learn it with the details. It's worth it. And this last example shows that in around 10 minutes you can set up a web server that delivers JSON. This is, I think, pretty fast. And of course now you can say, well, yes, but it is not HTTPS. It doesn't support CORS. Of course, there's an NPM module for this. And this is the second thing that you should take with you, that when you do JavaScript development today doesn't feel anymore like in the 90s. Lots of things have changed. It got way more professional. There's an enormous, huge ecosystem around JavaScript. And yeah, stay curious, be open, go out, talk to other JavaScript developers. There are lots of great JavaScript developers out there. And talk to your colleagues, go to meetups, go to conferences, try to learn. And yes, that's the bottom line of this keynote. Thanks for attending. And if any one of you thinks that it may be a good idea to talk to someone who knows some JavaScript, of course, you can contact us. Our website is thenativeweb.io, and our email address to contact us is hello@thenativeweb.io. We do consulting, we do training, we offer professional services, and so on. So if any one of you is interested, feel free. Have a nice day.